Good afternoon. Are we all flagging slightly? I can see some tired-looking faces out there. It's very bright up here, so I can't see all of you. Yes, it's that graveyard slot, isn't it? It's the last talk of the day. But don't worry, I'll get you a bit more excited and ready for your drinks. So, who am I? My name is Charlie Hull. I've been doing search for a very long time, nearly 25 years. Although my title these days is marketing director, I am a techie, don't worry. And I have written code, just not very recently. I've written books, I helped found the search network, I blog, I speak, I also run engagements. And in the past, I've been lots of other interesting things, including an engineer and a circus performer. In fact, the circus performers you'll see later on tonight are old friends of mine. I work for Open Source Connections, and we focus on three things: helping you understand your users and what they're doing with search, and how to improve their experience. We focus on the engineering for search and AI, helping you actually build things, and also the people and the process, the team you've got building search applications and AI applications, and how we can help you with the process of improving the quality of those results. And we run a conference called Haystack. CFP is still open, so please come to that. And see, this is just a short selection of some of the people we're working for. The one I'm most excited about is the last one. We're working with the AWS team on the OpenSearch search engine, helping add some user tracing. So we're going to know what people are doing with search to help us tune it. Anyway, less about me. Moving on. What I'm going to talk about is a brief history of how search engines actually work, just to give you some context, really, for why everything's changed with the advent of AI. What this means for search, some things that haven't really changed. And then I'm going to talk about some practical implementations of this, how we can build AI-powered search. Not all AI applications are search, but quite a lot of them are. When we're asking ChatGPT about something, we're trying to retrieve some information. That's a kind of search. And then I'm going to talk about measurement, which I think is absolutely key to make all of this stuff work. So, how do search engines work? Well, it's relatively simple. We take our source documents, generally text, we pull all the words out of them. We count all those words, we figure out how frequent or how rare those words are, and we put it all in a data structure called an inverted index. It's a bit like the index of the back of a book, but we've got every single word that was in every single document, and we know where they are, how frequent they are across each document, and also across the whole collection. That gives us some really useful statistics. And then someone types in a query. We take that query, maybe process it a bit, look in our index, try and find all the documents where that word or query is mentioned, and then list the documents, and there's your search results. And we use those statistics we know about the frequency of those words to figure out what are the most relevant documents for your query. Sounds simple. The trouble is, it doesn't always work. Search engines aren't very good at things that aren't text. They don't really understand the meaning of words. They don't really understand the difference between two synonyms, for example. They don't know they're the same thing. They're just storing statistics. What people type, and this is really important, what people type in their query isn't necessarily what you've got in your index. And this can be a big problem. You use a certain language to describe your product. Your customer comes along, types in something completely different. You call it lawn chair, they call it garden chair. If the two won't match up, you don't get a result. And there's various solutions to this, but it's all around language, basically. It's very hard to guess what a user is trying to do with your search engine, why they have come to your website and typed in a query. Are they just browsing? Are they interested in buying something? Are they looking for a specific piece of information? Are they just bored? We don't really know. It's really hard. And the other problem is relevance is subjective. When I present you a search result and you say that's a really good result, I may not agree with you. In fact, two different people may disagree about how relevant a particular result is. This is a problem. So how do we try and fix this? Well, let's take some representational queries, things we know people are looking for on our site, the sort of things we expect people to search for, maybe drawn from logs, and let's do some searches, see what comes out the other end. And then, and this is very important, we need to measure how good those results are. And we can do this by asking humans to judge the results, or we can look at clicks and see what people are actually clicking on or engaging with. And this is just a little thing here. This is a way of actually gathering those human judgments from a tool that we use, an open source tool called Cupid. And then when we got that measure of search quality, we can then try and change something and see what happens. I liken modern search engines to a bit like a mixing desk in a recording studio. There's hundreds of little knobs and sliders and whatever. We're trying to make it sound nice, but it's actually quite hard to work out which of those knobs and sliders to move to make things better for this particular use case. So actually, we need some kind of experimental methodology here. We need to try stuff, see what happens. Try something else, see what happens. And do that repeatedly using an experimental mindset until you hit some kind of acceptable KPI, which hopefully is linked to what your business is actually trying to do. So if we manage to make things more findable, perhaps more people will buy them, or download them, or engage with them, or apply for that job, whatever it is. And this works pretty well. And this is data-driven search tuning. This is key to what we do at Open Source Connections. And we help our clients build dashboards, carry out offline and online experiments, and get some kind of measurement of how good their search engine is working. So in the past, we've had lots of input from the NLP community. There's been lots of things from natural language processing we can use to make this a bit easier. We can try and understand the query. What kind of, is it nouns? Is it verbs? We can enrich the query by pulling in data from other places, maybe taxonomies or catalogs, and try and make the data more rich. Even we can automatically find synonyms for words from dictionaries or things like that. But it's always been part of search, but things have changed a bit. And this is how things have changed. You'll probably be aware, of course, of OpenAI, of ChatGPT, all of these things. And this is very exciting for the search community. We can now capture meaning. We can capture semantics with magical things called embeddings, which are great big arrays, as somebody said earlier today. They're basically multi-dimensional vectors. You can see a little picture there showing how, in this case, the vector for dried fish is closer to food. The vector for fishing boat is closer to tools. And this gives us an idea of similarity, and it's very useful for search. And it uses a machine learning model of language. Sometimes a large one, sometimes a small one, doesn't matter. And you store these embeddings in a vector database. Now, vector databases are great for search, but they can also do things like clustering, cluster similar things together, find similar things. And you can get much more results because you're not looking at exact word matching, which is great. They're also good because you can do multimodal searches. You can search for images with a text query because you can extract embeddings from those images as well. You can do multilingual search. There's some huge possibilities here. The flow looks similar, but it's a bit different. You've got this encoding step to make those embeddings and also on the query side as well. And our machines can generate plausible text. Note the use of the word plausible. Language models are great at completing things. They can complete your sentences for you, complete your search query even. They can summarize from sources. So instead of just getting a list of search results, you can get an answer, which is really exciting. I ask a question, I get an answer, not a bunch of things I need to follow up. Plausible, however, doesn't mean good or correct. And you can even use these large language models to judge the quality of search results. You can say, hey, ChatGPT, well, maybe not ChatGPT, but hey, language model, tell me how good this set of search results is, or this answer is, according to this question. You can use one LLM to even judge the results of another one. You can have conversations with your computer. You can talk to your PDFs. You can chat to your PDFs. I cannot think of a more tedious conversation you're going to have, but anyway, you can chat to your PDFs. Hooray. And you can do prompt engineering. We even carry out tasks using these systems. And yeah, general purpose AI is coming real soon now, like it has been for decades. Anyway, we're getting closer. The trouble is, it's not all good. LLMs hallucinate. They don't really know when they're wrong, and this can be very dangerous in some settings. Some people are trying to measure this. This is a company called Vectara, a partner of ours, and they have developed a model for measuring hallucination in LLMs, which is exciting. There can be some terrible things that could happen. Here's a supermarket app that basically made up recipes that emitted chlorine gas. And you may know this other one where a lawyer went to court with a bunch of cases that one of these systems had told him were real, and they weren't real, and the judge held him up on that. So it doesn't always work. Here's a more focused example. So one of the things we do at OSC is we have an open source query judgment tool. So what tools can be used to collect human judgments, human measurements of how good search results are? And so we asked that question to one of these systems. It came back with, yeah, the first, what's the second one? Cupid, that's the one we do. Crowdflower, that's a company that have this. Unfortunately, this first one doesn't exist. It entirely made it up. And that's a bit of a problem. We've also got bias. So the training data for any language model, any of these big systems, contains inherent biases. Perhaps they're more skewed towards a Western audience. Perhaps they're more skewed towards a particular gender. But yeah, there's problems here with the training data. It kind of has inherent biases. If you don't recognize those, you've got a problem. Existential fear. Do you like my AI will be back? AI will be, anyone? No, never mind. Okay, anyway, I think a lot of this is generated by the people who want to control the market. They want us to believe that these things are incredibly complicated and powerful and wonderful, and maybe they should be the ones to make decisions. Not sure about that one. And we've got panicked regulation. Do governments even understand AI a lot of the time? This is a headline from Wired after the recent summit on AI. It's not all doom and gloom, but there is a lot of kind of reactive things going on here. And license confusion. This is a particular bugbear of mine. Meta came out and said, we have released a new language model called Llama 2. It is open source. This was not true. They released it under their own license, which has restrictive clauses. Unfortunately, a lot of people have kept repeating that this is open source. Lots of journalists have said it's open source, and it's not open source. You may not think this is a problem, but if you're a business trying to adopt these technologies, you need to know what license the software is under, and that needs to go through your legal team. And if people just start inventing their own licenses and calling them open source, you've got a problem. So, also crazy money. There's stupid amounts of money being thrown at this. 4-week-old startups being given hundreds of millions of euros. That also sounds a bit panicky and crazy. And last but certainly not least, to train these models can involve huge planet-destroying compute. And I encourage you to check out the Green Software Foundation. First found out about them at an OpenUK event. They're doing marvelous things around trying to measure the carbon impact of computing processes. Please take a look. So what does this mean for search and search people? I mean, maybe if you asked me this question a year ago, I might be thinking, oh God, I'm out of a job. These ChatGPTs, everyone's going to use that. No one's going to use a search engine ever again. What's going to happen? Well, yeah, or you could say, hooray, it's all done. We can now go home. Search is solved. Unfortunately, it's not quite that simple. So the vector search engines we're talking about aren't magic. They can't do everything. Exact searches, they're not so good at. So if you have a part number, for example, a standard search engine will do very well on that query if set up correctly. You get a lot more results. They may not all be relevant. Your vectors may be, the first few may be quite close to your query, but then you get the other ones that are quite far away, but you're getting 100 back, and not all of them are very useful. What most people are doing now is some kind of hybrid approach. You combine your standard lexical search engine with a vector search engine, and you somehow blend the results together. How you do that is an exercise left for the reader, but it is being successfully applied. We've seen this being applied in e-commerce, for example. In the UK, major retailer in the UK, saw a couple of weeks ago they were doing this. And the other problem we have is this massive explosion in technologies. We've got search engines, they're all adding vectors. So the traditional open source search engines on the right there, they've all got vectors now, which is great because you get to keep your platform and you also get all the standard search features too. Then you've got vector-first databases. There's lots of startups, lots of funding going into this, where they just do vectors. They do some traditional search things as well, not always very well. They don't always have the features that have come out of search developments, but they're very excited, lots of very excitable young DevRel people rushing around the world telling you these things are marvelous, and there's huge amounts of money going into it. All the VCs are very excited. This is a brilliant site here just for trying to pick one of these vector databases. This is a very small snippet, all the ones available, but great project. It's all open source as well. Databases. You can have vectors in Postgres. You can have vectors in Oracle. You can have vectors in pretty much any database. They're all adding vectors. Again, may not be as performant as the vector-first databases. We've got frameworks for building AI systems. A couple of examples there. Llama Index is very popular. In some of these, you've got some wonderful things like Python notebooks. You can build fantastic prototypes. But can you take that to production? Maybe not with a Python notebook, but we'll see. There's a lot of prototypes out there. We're only just seeing it go into production. Models. Hugging Face, fantastic repository for models, where there are over 400,000 models to choose from. How on earth you select one, again, is an exercise left for the reader. Some people even building them in-house. Bloomberg, for example, have built a model for financial data. APIs, you can throw all of this at an API and get your embeddings back. You can, OpenAI do this, for example. Amazon, Microsoft, all the big players are offering their API. There's lots of startups doing it. So you've got huge choice, and this is difficult. In fact, there's problems as well. I mean, I saw this lovely picture someone put on Twitter there. Everyone will obviously get the reference. But if you build something on top of one of these companies and then all kind of shenanigans and politics happen, Sam Altman left OpenAPI and then he came back. And it's all a bit terrifying, if you're relying on that for a business application. Maybe we should have open models so we don't have to depend on an external company. And I'm sure this audience would agree with me that might be a good idea. There's other risks. This is a lovely quote from Simon Willison, who writes some brilliant things about LLMs. They don't come with a manual, they come with a Twitter influencer manual. Lots of people boast about the things they do, which is really frustrating. Explainability. Why did we get this answer? Why did we get this result? Because embeddings, because vectors. We got hallucination. So it's not always easy to understand why you got a particular result or not. Most of these models aren't trained on your data unless you fine-tune them or retrain them, which is expensive and takes time. So they won't understand your language inside your company, your application, your product set necessarily. It's the general case versus a specific case. So that's a bit of a problem. Security and access control. In enterprise search, for example, I've got to be able to security filter all the results. I don't want some of my employees even knowing about the existence of a document that talks about a feasibility study for a new office that's mysteriously 5 times smaller than the current office. Does that mean layoffs? Oh my God. So you've got to have some kind of security and filtering, harder to do with these vector engines, but you can do it with hybrid search. Anyway, it's hard. And also there's some people thinking, probably shouldn't send all this exciting private data off to OpenAI through its API. That feels like a security risk. Anyway, there's luckily some things that haven't changed. So search hasn't gone away. Some people thought that search was going to be replaced by AI. That's certainly not happening. We are still seeing a value in traditional search. We're getting some great new tools for our toolbox, which is wonderful. And there are similar things to focus on. I mean, I think, in the old days, data quality is a very important thing for search, and it's still a very important thing for AI. We've still got to build all the operations, the pipelines, the processes, and we've got to measure how good the results of these systems are. Also, many of the people doing this AI stuff haven't really done search before, so we've got a lot of new people turning up saying, how do we do this thing? And us old search heads go, yeah, we kind of worked that out a decade ago, and we tell them how to do it. But a lot of people coming from the AI world into search without necessarily the benefit of that experience, which is great. We've been doing machine learning in search for years, actually. There's lots of earlier implementations of machine learning. We've had, Dr. Vet, we've LSI, we've had learning to rank, which is very commonly used, and that's a machine learning-based technique. So we've got some of those skills and those capabilities, know how to do it well. And traditional techniques are still the best for many use cases. And some people would say, just use AI for the edge cases when all else fails. So I've done my standard search. I didn't get any results back because you typed in some crazy query. Well, maybe I now use a vector database which goes much wider and say, this is a good way to reduce, for example, the 0 result problem. You never want to present someone with 0 results for a query if you can avoid it. So maybe you can go wide and get some slightly related stuff that's accessed via vector. It's a bit like 2012 all over again. Everyone remember big data? Big data happened. You could use it to sell anything from servers to services. And then a lot of them, big data people actually, big companies went and bought search engine companies. Oracle bought a search engine company. Microsoft bought Fast. In fact, Hewlett-Packard bought Autonomy. That didn't go quite so well. But anyway, people bought search companies because they saw the expertise there. And it really feels to me like we're back here. Search is exciting again. People are focused on search. They're looking for experts. So, coming back to how to actually build some of this stuff, I've got a couple of examples for you. So this is something we did for the e-commerce arena, starting early last year. One of my ex-colleagues, Atita here, she built something on the Chorus platform, which is our open source example of how to build e-commerce search, totally open source. And we basically built a vector search system to show people how it could be done. We did this with our fake electronics shop, Chorus Electronics. And this worked really well. It did image search, text search, and here's some examples. One of the big problems in e-commerce search is the accessories problem. I type in notebook, trying to find a computer. I get back notebook cases, notebook power supplies, everything apart from the actual notebook. If you do it with a standard algorithm, you get that problem. With using text vectors, you get actual computers, which is great. Projector screens also work really well. That's another great query. here's an interesting one, a misspelling. So someone's trying to look for a toner cartridge, they've misspelled a couple of words, and you don't get any good results at all with standard search. But doing image vector, you get really good results. You actually get toner cartridges from Lexmark. Network cables was another really good one. In fact, you can search for blue network cable and get blue network cables when no one's actually typed the word blue in the product description, which is brilliant. We're doing this for a major EU client. It's going into production this year, and hopefully I'll be able to talk more about it soon, addressing that zero results case, which is exciting. And now this is the big one. This is the one that everyone is very, very excited about. Retrieval Augmented Generation, or RAG, or RAG. In fact, my LinkedIn is just full of people writing stuff about RAG because it's seen as the great white hope of search and AI. Anyway, what this does is basically the user asks a question. You then go to your search engine or vector search engine or both and get back a set of results. And then you tell your LLM, please, answer the question using those retrieved results. It grounds the LLM in truth. It says, answer the question, but only use these things as your reference. Don't go mad and just start making stuff up. Okay? So this is basically how it works. So we ask a question, who are Tesla's top competitors? We're some kind of financial on a business application here. And we ask our database, we say, please give me some results for this question. And back it comes with some results. And then we feed those results into our LLM and say, please answer this question using these documents as your sources, and hopefully the answer comes out. Tesla's top competitors include Ford, blah, 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 blah. So here's how we actually built this. So I can't show you the actual results because the content's private, but you get the general idea on the left there. There's some search results for that. And the detail is on the right. I'm not going to read all of it, but basically what it's doing is taking a bunch of data, chunking it up, doing vector search, coming back, and then saying, to the LLM, answer this question, but only using these references. And here's the actual prompt we use, which is interesting. And I've highlighted some of the important parts here. And the prompt basically tells it how to compile that answer. And it says, don't make things up. If only it was that simple. But basically, it's saying, please use these references. And you get, for example, when it has based an answer on something, it's saying, well, what's the actual reference source you used? Tell me where that came from. That's really valuable. And we're building this for a big global analytics firm. But interestingly, we built a measurement system first. Because this comes back to one of my points earlier. How can you fix and tune and improve these things without being able to measure the quality of what they're producing? And there's a lovely quote here from Lord Kelvin, often bastardized. When you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. I love that. Anyway, and as an electrical engineer, I've obviously got to have a Lord Kelvin quote in there. So, a couple of examples of this. We have our open source Cupid tool, which lets you collect human judgments. And earlier this year, we worked with a very new and exciting AI search company called Vectara on the West Coast US. And basically, we can now point this tool at that system, and they can use it to do searches, get results, get human judges to measure and to say how good those results are by rating them, and then calculate some metrics. And actually, we've extended this now, so we should be able to use this with pretty much any search engine. So that's really exciting. We can start applying these techniques of human judgments. And do you remember that loop I showed you earlier? Measure, do some queries, measure, and then try some experiments, and then iterate and try and tune and improve. We can use this for that. And then we got measuring RAG. So how do we do this? Well, let's take it step by step. Let's look at the R step first. We do our query, and we get back some results. Well, the good thing about this is that's just retrieval, really. We can do exactly the same thing we've done for search engines for a long time to rate the results, either with human judgments or with clicks, and then produce some kind of measurement to say how good these results were. So that's step one. And then we've got to do step two, which is how good is the eventual answer the LLM has produced. That's slightly harder. There are some techniques from information retrieval, which is the academic side of what I do. But generally, we need to figure out better ways of rating this. And there's a really interesting project here that I encourage you to check out called RAGAS, which comes up with some measures there for how good these systems are. It's a bit of a moving target, this. Again, one really powerful technique is to use an LLM to help you rate how good the results of the LLM were. So, coming to the end of my talk now, takeaways for you all. Search is exciting again. It's a very exciting time to be in search. Perhaps if you've got a project and you want to get funding for it internally, externally, whatever, call it an AI project. You're more likely to get funding. The executives are very excited. They've all read those articles in Forbes magazine, usually illustrated with a picture of a beautiful female android. Have you ever noticed that? They all have that illustration. And they want to do AI. There's lots of new people coming into the search business. I find this hugely exciting. We can teach them, we can pass on our skills, we can get more excitement about search. AI techniques can help to solve some of our oldest challenges. That understanding piece we've always found hard with these engines who are just counting words. There's real promise here, but we should stay calm and pragmatic and not get overexcited. It's not as simple as that, but it's hugely promising. You need to keep up. This stuff is changing very, very quickly. 400,000 models on Hugging Face. There's new articles every day. There's new people writing about this stuff every day. Don't believe all of it. A little bit of cynicism here is not a bad thing. And there are challenges around open source AI where the kind of innovation is outpacing the legislation or the licenses. And I think that is a problem. I don't like the idea of big companies telling us what open source is and isn't. It's not their job. Some things haven't changed. Search doesn't operate in a vacuum. What is the use case? What is the application you're trying to build? What are you trying to solve? That's really important to focus on. Just because you have AI doesn't mean you should use it. There are significant risks. Try and quantify those risks, trying to understand those risks. It can be slow and costly to implement. I've heard anecdotal stories that the index size for a vector database could be 7 or 8 times as big as the one for a standard search engine. So you've got operational challenges there. This is going to cost time and money. But pragmatic, cheap, and open source solutions can work. You can use small models. You can use open source databases. You can open source search engines. You can use open source large language models. And you can build this stuff. And we're seeing fantastic implementations coming out of places like Elsevier, for example. They've just built an amazing thing for searching literature there. We're seeing major retailers do this across Europe and the US. So it can be done. But remember to measure. You cannot improve something unless you measure it. If that's one thing I remember from this talk, is the way to improve all kinds of search, be it AI-powered or not, is to measure. Thank you very much. Do get in touch if you need any help building search or AI. And I'm very happy to take a question or two if we have time. Thank you.